An outdoor receptacle must be protected by a ground fault circuit interrupter, or GFCI, to prevent shock hazards. The breaker should be rated for the maximum current draw of the travel trailer, which is typically 30 amps. Using a regular 30 amp breaker with number 10 wire may not provide adequate protection. A motor load, such as an air conditioner, requires a different type of breaker than a standard breaker. Using a 30 amp breaker for a number 10 wire rated for a motor load may result in overheating or damage. If there are concerns about competency and if it is believed that a license was obtained fraudulently, consider contacting firstly the State Licensing Board. Report concerns to the licensing board that issued the master electrician license. They may investigate and take disciplinary action. Secondly, the local building department. Report any electrical work that is believed to violate code requirements. They can inspect the work and issue citations or permits if needed. Thirdly, the insurance company. If it is believed that work has created a hazard, inform the insurance company. They may deny coverage or increase premiums if they determine that the work was unsafe. It's important to approach the situation respectfully and with evidence to support any concerns. Consider the following steps. Firstly, gather information. Collect evidence such as photos, documentation, or witness statements that support your concerns. Secondly, express concerns. Politely express concerns about the safety of the electrical work and the potential legal implications. Thirdly, provide evidence. Present the evidence to support claims and explain how they violate code requirements. Fourthly, request a second opinion. Offer to have a qualified electrician inspect the work to confirm findings. Fifthly, document the conversation. Keep a record of the conversation, including the date, time, and what was discussed. If a partner is unwilling to address the concerns or disputes the findings, it may be necessary to escalate the issue to the appropriate authorities. Remember that safety and the safety of others should be the top priority. Regarding the specific issues presented, let's delve into the technical aspects to ensure a clear understanding of the code violations and potential dangers. Firstly, the absence of GFCI protection for an outdoor 120-volt receptacle is a significant safety hazard and a direct violation of the National Electrical Code, or NEC. GFCI protection is mandatory for all 120-volt, 15-amp and 20-amp receptacles installed in damp or wet locations, which includes outdoor installations. The purpose of a GFCI is to detect ground faults, which occur when current leaks from a circuit to ground. This can happen when someone comes into contact with a live wire or a metallic object that has become energized due to a fault. A GFCI works by monitoring the current flowing into and out of a circuit. If there is a difference of more than 5 milliamps, the GFCI will trip, cutting off power to the circuit within milliseconds. This rapid response time is crucial in preventing electrocution. Installing a standard receptacle without GFCI protection in an outdoor location exposes users to a significant risk of electric shock, especially in wet conditions. The NEC mandates GFCI protection to mitigate this risk and ensure user safety. Secondly, the use of a regular 30-amp breaker with number 10 wire for a travel trailer receptacle raises concerns about both overcurrent protection and conductor ampacity. While a 30-amp breaker is appropriate for a 30-amp receptacle, the number 10 wire must be properly rated for the load. According to NEC Table 310.16, number 10 copper wire has an ampacity of 30 amps when used in a typical residential or commercial installation with an ambient temperature of 30 degrees Celsius or 86 degrees Fahrenheit. However, several factors can affect the ampacity of a conductor, including the ambient temperature, a number of conductors in a raceway or cable, and the termination temperature rating of the connected equipment. If the ambient temperature is higher than 30 degrees Celsius, the ampacity of the number 10 wire must be derated according to NEC Table 310.15. Similarly, if there are more than 3 current-carrying conductors in a raceway or cable, the ampacity must be adjusted according to NEC Table 310.15. Additionally, the termination temperature rating of the receptacle and breaker must be considered. If the equipment is only rated for 60 degrees Celsius, the ampacity of the number 10 wire must be limited to the 60 degrees Celsius column in NEC Table 310.16, which is 25 amps. In this case, the 30 amp breaker would not provide adequate protection for the number 10 wire. To ensure proper overcurrent protection, the breaker must be sized to protect the conductor. If the number 10 wire is only rated for 25 amps due to temperature dating or termination limitations, a 25 amp breaker should be used instead of a 30 amp breaker. This will prevent the wire from overheating and potentially causing a fire. Thirdly, replacing a perfectly good 50 amp air conditioner breaker with a 30 amp breaker because number 10 wire was running to the air conditioner indicates a misunderstanding of motor loads and overcurrent protection. Air conditioners and other motor-operated appliances have specific requirements for overcurrent protection due to their inrush current characteristics. When a motor starts, it draws a significantly higher current than its running current. This inrush current can be several times the motor's full load current and can last for several seconds. Standard circuit breakers are not designed to handle these high inrush currents and may trip unnecessarily if used for motor loads. To accommodate the inrush current of a motor, the NEC allows the use of inverse time circuit breakers or time delay fuses, which have a built-in delay that allows them to withstand temporary overloads without tripping. The NEC specifies the maximum allowable overcurrent protection for motor circuits in Article 430. The size of the overcurrent protection device depends on the motor's full load current, the type of motor, and the type of overcurrent protection device used. In general, the overcurrent protection device should not exceed 250% of the motor's full load current for inverse time circuit breakers or 175% for time delay fuses. Using a 30 amp breaker for an air conditioner circuit that was previously protected by a 50 amp breaker is likely to cause nuisance tripping, especially during motor startup. This can be frustrating for the user and can also damage the air conditioner motor over time. The correct approach is to determine the air conditioner's full load current from the nameplate and select an overcurrent protection device that meets the requirements of NEC Article 430. The conductor size should also be sized according to NEC Article 430, taking into account the motor's full load current and any applicable dating factors. In summary, the electrical installations described in the scenario violate several key provisions of the NEC and pose significant safety hazards. The absence of GFCI protection for the outdoor receptacle creates a risk of electric shock, while the undersized breaker for the air conditioner can cause nuisance tripping and potential damage to the motor. It is crucial to address these issues promptly to ensure the safety of users and prevent potential fires or other electrical accidents. Consulting with a qualified electrician and adhering to the NEC are essential steps in ensuring safe and compliant electrical installations. Remember, electrical safety is paramount, and it is always best to err on the side of caution when dealing with electrical systems. Regarding the legal and ethical implications, it is crucial to address concerns about a partner's competency and potential falsification of work history or experience. Firstly, documenting all concerns is paramount. Maintaining a detailed record of specific incidents, code violations, and any conversations related to these issues is essential. This documentation can serve as evidence if further action is necessary. Secondly, approaching the partner with concerns in a professional and respectful manner is important. Clearly and calmly explain the observed issues, providing specific examples and referencing relevant code sections or standards. Avoid accusatory language and focus on ensuring safety and compliance. Thirdly, seeking a second opinion from another qualified electrician or electrical inspector is advisable. An independent assessment can validate concerns and provide additional support for addressing the issues with the partner. Fourthly, reporting concerns to the appropriate authorities may be necessary if the partner is unwilling to address the issues or if the safety concerns persist. This may involve contacting the state licensing board, local building department, or other regulatory agencies. Fifthly, consulting with an attorney may be necessary to understand legal rights and obligations, especially if the situation involves potential fraud or misrepresentation. An attorney can provide guidance on how to proceed and protect one's interests. Regarding specific code references, NEC Article 210.8 addresses GFCI protection for dwelling units, including outdoor receptacles. NEC Table 310.16 provides the allowable ampacities of insulated conductors based on their size and temperature rating. NEC Article 430 covers motors, motor circuits, and overload protection. NEC Article 250 addresses grounding and bonding requirements for electrical systems. Regarding the potential consequences of unsafe electrical work, these can range from minor inconveniences to serious injuries or fatalities. Electrical shocks can cause burns, muscle contractions, and cardiac arrest. Electrical fires can cause extensive property damage and loss of life. Improper grounding can lead to equipment damage and increased risk of electrical shock. Failure to comply with electrical codes and standards can result in fines, penalties, and legal liabilities. In addition to the technical and legal aspects, it is also important to consider the ethical implications of unsafe electrical work. Electricians have a responsibility to protect the public and ensure that electrical installations are safe and compliant. Cutting corners or disregarding code requirements can have serious consequences and can erode public trust in the electrical profession. In conclusion, addressing concerns about a partner's competency in potential code violations requires a multifaceted approach that includes documentation, communication, independent assessment, and reporting to the appropriate authorities. By taking these steps, it is possible to protect oneself, ensure the safety of others, and uphold the integrity of the electrical profession. The key is to act responsibly and ethically, prioritizing safety and compliance above all else. It's also important to be aware of the specific regulations and requirements in the local jurisdiction, as these may vary from place to place. Consulting with local electrical inspectors or code officials can provide valuable guidance and ensure that all work is performed in accordance with applicable codes and standards. Finally, remember that electrical work is not a DIY project. It requires specialized knowledge, skills, and tools. If you are not a qualified electrician, it is always best to hire a professional to perform electrical work. This will ensure that the work is done safely and correctly, and that it complies with all applicable codes and standards.